Welcome to the Terraform product keynote. To kick us off today, me and Mitchell wanted to spend a little bit of time talking about the history of Terraform itself and how we came up with the idea, the sort of approach that we ended up taking. And one of the, I almost relate it back all the way to when we first met, right? So we often talk about the origin story of HashiCorp and how me and Mitchell met. And it goes back to our time at the University of Washington, where we were both on a research project figuring out, how to enable the scientific compute cloud. This was early days, circa 2007, so early for sort of public cloud infrastructure. Really, it was, Amazon was, your only option, and it was very primitive at the time. So a lot of our focus was, how do you actually build and manage infrastructure in a public cloud, given the sort of dearth of tooling that existed? And so one of the most painful parts of that was, how do you provision and manage the life cycle of infrastructure? And so, we've taken multiple different stabs at this problem over the last few years, from, our efforts on the research project to kind of projects we hacked on in our spare time and presented at user groups, to some of the efforts we did sort of after college and, in a number of startups. And then ultimately to kind of our efforts at HashiCorp. So, a problem space that we spent a lot of time thinking about and chewing on, really no strangers to it. But I thought what might be helpful is if, Mitchell, maybe you want to share a little bit of, how did you start to think about the infrastructure as code sort of paradigm, and what was your first exposure to that way of thinking about it?
Yeah, I think my first exposure to something like that was probably, configuration management and actually setting up and installing software on servers. At the time, we viewed servers more as pets rather than cattle in that analogy. You tend to set up a server, keep it running for a very long period of time. And I thought the tooling around that, circa 2008, 2009 was pretty good. I was happy using tools like Chef and Puppet to do things like that. And I thought a really big missing, a big gap in setting that stuff up was still creating the servers, creating the load balancers and things like that. I still felt like I was clicking a lot to do that, and it was not very automatable. And so I think it was 2009, Amazon announced CloudFormation. And I wrote a blog post, I think a day after that release or something, talking about how excited I was about this CloudFormation release, because it really felt like a pain point that I had been imagining in my head was validated, and this was a solution to that. So I really quickly played with CloudFormation. And one thing I sort of attached to right away is, I wanted to improve it, and my background and my passions really lied with open source. And here was this closed source, proprietary, all Amazon tool that I couldn't improve. I wanted to add support for more features and more resources that weren't supported by CloudFormation but available in AWS, and I just couldn't do it. At the same time, there were some other systems, like Linode and other sort of VPS providers that I wanted a similar CloudFormation-like experience with, and I couldn't get it again because the system was a closed ecosystem. And so I wrote this blog post saying, this is a really fantastic idea. I'm super excited about CloudFormation. I can't wait until somebody does this in an open source fashion that can support any sort of infrastructure provider. And I sort of published this blog post thinking, any day now, someone was going to do it, whether it's a new company or an existing config management company or someone else, anybody. This is still before HashiCorp existed, before we wrote any of our open source projects. I was, a second-year student in college, so I certainly didn't expect that we would do it. But fast forward sort of 4 or 5 years later, and now I'm graduated, I'm working in a job, and I still have this problem, and it's still not solved. And I thought, maybe I guess, we will do it. We will give this a shot. And I was feeling a little bit more confident then that we actually had the knowledge and expertise to be able to pull this off. And that was really the basis of Terraform and how Terraform came to be. It was something I viewed as sort of an open source ecosystem to be able to manage any infrastructure provider as code, and to foster this community where everybody helped make the support for more and more resources grow at a rate that no single company could do on their own. And to my happiness, that is how it turned out. And Terraform is this really vibrant, active community that makes Terraform work for pretty much anything in the world with an API. So that's really how Terraform came to be. and it was based really in this notion of let's automate everything.
Well, and I think, Mitchell, the way you sort of describe it, I think it makes it seem like there was this sort of obvious jump for us from sort of how we thought about the problem and what we wanted the solution to look like to sort of Terraform as we know and think about it today. But I think sort of the reality that sort of me and you lived through was, I think multiple fits and starts of us sort of thinking about this problem space, trying different sort of approaches to it, feeling like it wasn't quite right, and then sort of retrying and kind of sort of iteratively getting there, right? So, if I share just a little of the history, I feel like we both agreed that from the user's configuration perspective, we wanted something that felt like a declarative statement, right? Very much similar to Puppet, similar in many ways actually to CloudFormation, though I think both of us had a bit of an allergic reaction to the JSON syntax of CloudFormation. So I think we knew we wanted something that was going to be a user-friendly language, right? And I think there was a lot of work for us to kind of evolve HCL, the HashiCorp config language, to where it is for Terraform. But we wanted something user-friendly. We wanted something declarative. And then I think we actually didn't have a good understanding necessarily of what the implementation would look like, right? And I think I think Terraform, as we think of it today, is maybe version 3 from sort of our internal approaches. I think maybe it'd be helpful if you want to talk through a little bit of, what were those different sort of, left turns that we took that ended up being a dead end, or right turns that we took that we decided we had to change course, just in terms of the design and the approach that we ultimately took.
Yeah, I think that's a really good point, and I think I was a little bit jaded in the history there, forgetting all those false starts, or maybe I was purposely trying to forget those false starts. But Terraform really started as, I think, augmenting existing configuration management tools to try to manage infrastructure. One of the first things that we thought was, hey, Puppet, Chef, those sorts of tools have a syntax that's close to what we want, and manage software installations close to what we want, so maybe they can manage infrastructure as well. And so we first started out by sort of implementing it that way. And some of the false starts we sort of hit really quickly with that one was a lot of the tools then were agent-based, and the agent in this case didn't make sense because we were sort of an outside actor, operating on something from the outside versus something running on a machine operating on it from the inside. So architecturally it felt a little bit weird. There were some missing features that we felt that were really important for infrastructure that were less important for software. And one of the big one, I think, that really sort of put us over the edge towards building our own sort of solution was this concept of create before destroy. One of the first features we hit was, hey, I want to stand up a new EC2 instance and add it to a load balancer before I delete the old one. It's a really basic concept, but I think that desire permeates really deeply into how the system works, as well as all the features around it. And so those sorts of things really push us away from, I don't think the config management way of thinking and architecting applies perfectly to this. And so we started moving into the Terraform world. And I think some of the surprises we had in Terraform was people want to do a lot more with infrastructure than we imagined was possible, but made total sense. So bringing things like modules to make reusable infrastructure blueprints, and things like looping constructs and conditionals and things like that. In our original sort of basic designs and sort of basic needs for the startup we were at the time, the size startup we were at the time, we didn't need that, and we were pretty happy with what we built. But as sort of realities of the world came into this tool, we realized that more and more of these things were super valuable to support more complex use cases. But all of this sort of came back to needing sort of a specialized runtime, a specialized core focused on infrastructure management. And I'm happy with where Terraform is at today, but along the way, I don't think any other sort of solution really hit that for us.
Yeah, and I think even internally, we felt like not only were the existing approaches wrong, but I think we experimented with a few different ones as well. I think, initially it was a bit more of a imperative CRUD-based model where we had to sort of explicitly write in, what were the CRUD operations, and then the system would help us order it. We felt like that was kind of heavy and sort of difficult for users to deal with. So I think, pretty quickly we transitioned off of that and said the core engine should be responsible for the ordering of the CRUD operations. But then how do you make the kind of bigger system make sense? And I think, we played around initially with a model around could each resource be sort of a finite state machine, and we modeled it as a series of sort of transformations between state, and then each FSM would be able to interact with other state machines so that you could create dependencies to say, hey, my load balancer depends upon the VM. And then I think, quickly we started asking ourselves, how do I do these really complex, transformations across these different, FSMs, and what happens when I have these sort of undefined states? So we felt like, this model doesn't make sense. And then we transitioned to sort of an actor-based model where each resource was almost an actor, and there was sort of a message passing interface between them. And this allowed the system to be highly concurrent the way Terraform was today, but also kind of confusing for users to deal with, and very difficult to actually build a programming model around, because it was so, the ordering of execution was so random and everything was happening concurrently. So I think we kind of tried the FSM model, that didn't feel right. We tried the imperative model, that didn't feel right. We tried the actor-based model, that didn't feel right. And I feel like where we ultimately got to was sort of this sort of graph-based engine, where we model all the infrastructure as a graph, and that the engine has a very predictable, execution order. It has sort of a limited concurrency on purpose, so it doesn't kind of overwhelm the underlying cloud systems, nor does it overwhelm the user with just sort of completely randomized output. But I think this kind of fourth approach had a bunch of the nice benefits of it freed you from the imperative logic. It wasn't terribly complicated if you wanted to write integrations, right? The Terraform providers are basically just CRUD, right? You just tell the engine how to deal with the CRUD, and then it's responsible for the ordering on your behalf. But, I think there was this sort of evolution of approach, right? And I think the other piece, is even the way we write providers, I think, changed quite a bit, right? With Terraform 0.1, there was a lot of work, right? There was a very raw interface between sort of Terraform core and the engine itself to what a provider had to implement, which was really all of the delta logic, all of the CRUD logic, really figuring out some of these edge cases that were pretty complex. And I think it was actually you who identified, hey, this is too difficult, this is too painful for somebody else to try and integrate with Terraform. We need to lower the bar. So I'm curious sort of like how that, I guess the first-hand experience of writing a Terraform provider and the pain involved, how did that ultimately sort of lead to your thinking around the notion of helper schema and the frameworks around Terraform providers?
Yeah, I think one thing I'm really proud of HashiCorp tools in general over the years is I think we've always done a really excellent job of building approachable interfaces for people to extend our software. And it's learning over multiple products. I mean, we had Vagrant first, they had plugins, and then we had Packer, which had plugins, and Terraform was the next tool, and I sort of learned from those and learned that it's very important for writing a plugin to be as easy as possible, because these tools that are glue, like Terraform is really a glue tool that orchestrates all these different resources and providers for these glue tools. They sort of live or die by the community that grows around them. And so if it's very hard to extend them, then the core itself, no matter how good it is, just won't really survive. And so it really came from that first experience. I think we were like a week out from releasing 0.1, and we had 3 of us sweating in a New York summer in an apartment trying to build providers as quickly as possible, and just realizing how I couldn't imagine anybody other than us who had built the core of the system writing these providers. And it was a little too soon to release to fix that, so we shipped 0.1, but I think really quickly, right after 0.1, or it might have been just before, but right on the edge there, I wrote a framework that effectively survived until a few months ago when we're starting to see some major changes now, but wrote this framework that allowed people to easily write providers. I like to call it, Ruby on Rails for infrastructure as code. It was really just a really quick way to write a provider, and I think it was a success because there's over, I think, 200 providers today. So it's worked pretty well, and I'm really happy about that.
Well, and I think, to your point, actually, I think there's over 300 providers today. So certainly there's a little bit of, proof is in the pudding on, the difficulty of the providers. But, I think this actually brings up another interesting point, which was, for a very long time, I don't think it was obvious to us that we'd sort of got the problem right with Terraform. I think, today people often say, Terraform's an overnight success, and they kind of see the usage of it. But I think the reality is, well into 12 months, 18 months after release, there was sort of a flat line of Terraform adoption and usage. It wasn't sort of a vibrant community the way it is today. And so I think there's this sort of interesting dilemma, which was sort of like the conviction we felt on this being the right approach versus sort of helping bring the market and helping bring kind of users with us. Curious if there's anything you want to share, Mitchell, from sort of that period in terms of like, how you thought about the conviction we had in terms of the approach and the architecture and kind of infrastructure as code as the answer versus sort of just what the general sentiment was in terms of people thinking about infrastructure management.
Yeah, luckily we've had very few overnight successes, especially at that time, so I was pretty familiar with how that felt. And Terraform to me felt really similar to how I felt about Vagrant when that came out. Terraform wasn't super popular early on, like you said. It was about 12 months of slow growth. But every time I used Terraform, it just felt like the right solution. It was fun to use. It solved my problem. It was fast. It was, it gave me a lot of confidence in what I was trying to do. And so it just felt right. And I didn't see anything else filling that gap. There was no other option for me to try anything else. And so I felt really good about it. And I think that helped really, give us that conviction to keep working on it and keep growing the community into sort of what it is today. And luckily, for a lot of different reasons, Terraform got a lot better, the core got a lot better, early contributors came on board and built a lot of great providers, early partners came on board and started pushing Terraform a bit more, and all of that came together to growing Terraform into the success that it is today. And I think another funny part of sort of that history is because it took so long to get that initial bit of success, I think there's some question about, did we plan on monetizing this thing? How are we thinking about making it successful as an open source project versus monetizing it? And Armon, I think it'd be helpful if you talked about our views towards commercializing Terraform in particular.
Yeah, it's a great point. And I think this applies to not just Terraform, but really like the approach we took with all of our open source, which I think our philosophy has been, has been pretty consistent with all the products, which is really, really stay focused on what is the problem the end user is trying to solve with the open source tool, and let's make that excellent, right? Let's make the experience excellent. Let's make the technical capabilities needed for that excellent. And let's really focus on making sure if you're a practitioner, you're an end user trying to solve, provisioning problems with Terraform or security problems with Vault or networking problems with Console, et cetera, make that an excellent experience. And that's not the focus of where we commercialize. Where we commercialize is really looking at, great, once you move from I'm an individual solving this problem to, I'm a team within a larger company or a larger corporation, or I'm a massive corporation and I'm trying to provide, Terraform as a service across, thousands of developers, or, Vault as a service across dozens of different application teams. I think that's where we really look in terms of what are those challenges that come with that type of scale. Some of those might be just true scaling challenge of multi-data center and the need to replicate data and things like that. Some of those might be driven by compliance requirements, right? You're a big company, you need, FIPS certification or PCI or FedRAMP or, et cetera. And then some of them are just truly collaboration challenges, right? If I have dozens, hundreds, thousands of people trying to collaborate, how do I do that safely? How do I do that, where I'm managing, access controls and audit capability and single sign-on, et cetera, et cetera. How do I put the guardrails in place to say, great, I want to have hundreds of people work together, but I want to do it in a way that I'm actually managing sort of, the risk around that. So I think that's been a consistent way that we've sort of thought about monetizing all this stuff, certainly for the first few years. I'm trying to think with Terraform, certainly the first few years that it existed, it was purely a focus on the open source and the experience around it. And I think more recently, it's really been around Terraform Cloud and Terraform Enterprise. And even with Terraform Cloud, what we really look at is like, great, for small teams, can we bring some of this collaboration capability and make it free, right? If you're a team of 1, 2, 3, 5 people, go and use Terraform Cloud for free really tries to solve some of those challenges of small team collaboration. And then it has those capabilities that you need sort of as you get to scale. And I think this is actually probably a good transition point. At this point, I would like to introduce Robbie Tung, who's the product manager for Terraform, to share a little bit of the product updates and what's planned for Terraform and the ecosystem around it.
Hi, my name is Robbie Tung from the product team at HashiCorp. I'm super excited to speak to you today about what we've been working on in the infrastructure product line and let's just kick it off with Vagrant and Packer. So Vagrant and Packer continue to be some of the most popular OSS tools in the DevOps space, which is probably not a surprise to a lot of people. Vagrant, kicking off, is one of my introductions to the HashiCorp toolset, as I'm sure it was for quite a lot of people. And today, a huge number of people still use Vagrant to work with a variety of different kinds of environments. Vagrant Cloud, as you can kind of see, has only bolstered that. With Vagrant 2.3, the GA launch for improved triggers and full config disk support, as well as some enhanced security features and Windows support, are coming down the line. On Packer, 1.6.4 will kick off a number of releases which are going to focus more heavily on builders and the way they interact with the core Packer experience. We want to ensure a solid flow of the way the most popular builders are used, while setting up future functionality for the way people work with non-core builders as well for their own unique environments. These products are important to a lot of people with the way they work today, and so that's why we've spent a little bit of time talking about them. But it's also true for Terraform. It's also an important tool that a lot of people use, and Terraform is quite a big product at this point. It's three pieces that we're going to talk about in detail. The open source project, Terraform Enterprise and Terraform Cloud are platform products, and then finally the Terraform provider ecosystem. So starting with the open source project, it's been a huge couple of months. With the release of 0.12, the team was working hard to stabilize all of the functionality and all of the features necessary to introduce something like HCL2. They were also working on a lot of important features and have been ever since then as we move towards 1.0. With 0.13 being GA'd, the team is now fully focused on the final steps that take us in that direction to 1.0. One of our core engineers, Kristen, gave a talk on what makes a 1.0 release for us on the Terraform team, and she covered how seriously we take that. With 0.14, we're rounding out a lot of the functionality and changes that we consider core to the infrastructure as code experience, and we'll be looking to get the community's feedback. As always, excited to hear what you think about some of those features. After that, we're going to take the necessary stability steps towards moving towards 1.0 in the future. And does that mean that there will be another major release after 0.14? It's hard to say right now, but I'd recommend checking out Kristen's talk for more details about, again, what we think about that. That being said, I kind of want to talk a little bit about some of my favorite features from the 0.13 GA. Module for each and module count functions were the top of the list of things that we wanted to work on after 0.12. Both, unsurprisingly, were at the center of the 0.13 release. The applications for each are extensive, especially in lots of places where iterating over a set of things is going to be useful. And inside module development, they often become even more powerful. This kind of speaks to the way that we wanted to finish out functionality and code experiences that we started with the introduction of HCL2. It was such a big step forward, and there were so many improvements that went into that language change that we were able to finish out these experiences because of the hard work that went into 0.12. A funny thing about for each is that Mitchell himself actually was a strong advocate of us closing out for each and count in modules quite soon after 0.12. It turns out he has written a few modules in his time at HashiCorp, and he definitely wanted to see that functionality in the OSS project. Moving on to, I guess, my personal favorite feature, which is variable validation. Quite a weird thing to say, but it's one of my favorite features because of how often I'm able to make mistakes when I'm writing config, just personally. So having one or more validation blocks to be able to go into as much detail as I want as to the kind of validation I want to kick back when I'm trying to find a mistake that I've made is really nice. In fact, the example that you can see is the one that we used in the blog post to announce it, and it felt somewhat like a personal attack because this is definitely something I've done a lot, messing up the AMI string. I don't really want to think about how many runs in Terraform Cloud have errored out because I have got that wrong. If the Terraform Cloud team is watching this, please do not tell me. So that's open source, and up next I'd kind of like to cover a few brief updates about Terraform Enterprise and Terraform Cloud. I want to talk about the history of Terraform Cloud because The last year has been quite important for that product. In May of last year, we announced remote state management for everybody on Terraform Cloud. We spent a lot of time building an enterprise collaboration project around Terraform, and we'd seen a lot of teams get started and have issues when collaborating on Terraform at scale. The first issue that customers and people usually run into is state management. That's often like the first hurdle. And so to test out if other people felt the same way that we felt about this, we launched a free beta where anybody could sign up for Terraform Cloud and get free state management from the SaaS platform. This went really well, and we started to look at a base set of features and functions that would allow teams and solo developers to get started with the best practices for collaborating with Terraform. These included the version control-backed workflow and the module registry. These collaboration tools were, again, taken from the things that we'd learned from building the enterprise product and shipping that to customers. Moving on, we then introduced paid functionality with the paid tiers. The features that went into this were Sentinel, our policy as code language, and cost estimation, as well as the ability to do more concurrent runs on the platform, because at this point, early customers were starting to push the platform further, and this was a functionality that we wanted to offer at that stage. Again, these things were taken with the knowledge of the things that we'd learned from the enterprise platform. At this point, we'd been serving some of the largest businesses in the world with Terraform Enterprise, and so moving into paid functionality was something that we could easily do. That takes us to today, where we've just recently launched the business tier for the Terraform Cloud product. Like with everything, we designed it based on the feedback from our users. Many customers at this point were starting to use Terraform Cloud as a mission-critical piece of their kind of infrastructure provisioning story. And that's an amazing thing for us to hear, but it's also a responsibility that we take incredibly seriously. The business tier was built with this in mind. So SSO with Okta and Azure Active Directory, audit logging with Splunk, and also with the API endpoints, as well as cloud agents were all rolled into this tier. I'm really excited about the cloud agents because the ability to run Terraform locally and have it work with our platform opens up a lot of possibilities for customers who are running against multiple different environments in different places, or just have something really custom in their environment that they want to have Terraform be aware of when it's running. This was a kind of nice switch because we'd started by taking things from the enterprise product and pushing them into cloud to try and iterate. But we're now developing features in cloud, iterating over them quickly, and we're going to be bringing some of them back into the enterprise product. So it's a kind of nice reversal of the way things have worked, and it kind of like rounds out where we are today. Today, Terraform Cloud has seen more activity than we could have possibly dreamed of. We knew there was definitely going to be demand for collaborating with Terraform, and so we're really excited with all of the usage that we've seen. We're working on the next set of features and functionality to make the experience even better. And so a huge thanks, I guess, to all of our users on the platform today who are helping us make the product better. And on that note, straight after this is a talk from Kyle and Petros on the Terraform team called From CLI to Cloud and Back, where they'll be covering some of the things that I've discussed in the open source world, as well as how those work with Terraform Cloud, possibly even delving into some of the new things from 0.4t. And so definitely catch that. It's going to be a really good way to get more detail, more technical examples of how these features work. So finally, I just want to touch on the Terraform ecosystem. The Terraform ecosystem incorporates our providers and also the modules that people create to create deployable infrastructure patterns with those providers. It's an integral part to the infrastructure as code experience, and it has been growing consistently. One of the things that's so great about it is the community. There are a lot of developers out there writing Terraform modules for things that they want to see instrumented with infrastructure as code. And there's even more developers than that writing modules to create those best practice patterns that they can deploy. The cool thing about this is that everybody is doing it on the registry, and so new developers coming into this space can benefit from all of the activity and all of the work that's going on there. The numbers grow so much actually that it's hard to do a slide with the right scale of the numbers because they change so quickly, and I guess that's a good problem to have. We're also incredibly fortunate in this space to have working relationships with the largest cloud providers. These partnerships are ensuring a level of collaboration and a quality of an integration that is actually really hard to replicate outside of Terraform. We're working closely with them to ensure that fixes happen for the next releases, and to make sure that the bar is always there for anybody who's going to be like using either one of the modules or one of the providers associated with them. We also get to work on larger projects with these partners that will kind of actively improve the quality of the ecosystem as a whole, and hopefully we're going to be able to talk more about them throughout the year. However, the biggest increase in providers comes from our community, the ones I was mentioning earlier, who are constantly adding new things every day that they want to instrument. And with that amount of interaction and attention, we want to make sure that we're setting up for scale with our community. So we have been doing that in the last few months. In 0.13, we added provider source, and this enables a better story for declaring the source of your providers explicitly. You can declare whether you want to fetch them from the registry, or whether you want to fetch them from a custom location that makes sense to you. That, combined with the version constraints, allows you Terraform config that can be fully explicit from about its dependencies. It makes the behavior of a config much more dependable, just predictable in general. And perhaps much more importantly, this functionality kind of sets up the stage for a much larger expansion of the community providers, which we mentioned. With the combination of that plus the new registry and the work that went into all of this, we were able to launch providers in the registry earlier this year, which showcases not only obviously the top cloud integrations that we have, but the continually growing number of community providers. Like I said before, the community effort is the most important thing about this. It really is exciting that it's all coming together on the registry, that people can benefit from that. And with the recently redesigned navigation, we've tried to make it even clearer on the registry for new users coming in to understand what they can expect when they're interacting with a provider. We have 3 tiers: official, verified, and community. Official, stating that our engineers will be backing it and they'll be working on that provider. Partner and verified, meaning that they can expect support from one of our many partner teams. It'll be a partner-led effort. And community means that the community is leading the effort on that provider. We're looking to make the registry experience even closer to Terraform Cloud and Terraform Enterprise this year, so please stay tuned for more to come from that regard. So just finally, I want to thank everybody who works on Terraform and everybody who makes this possible, from the engineers, the product people, the designers, the support people, everybody who works on Terraform at HashiCorp. An enormous thank you for everything you've done to make this project great. And then also just the community. The community is such an important part of what we do. The product wouldn't be where it is today without all of the things that the community does to make it great, to push it further, and to continually just give us feedback on ways that we can move that make sense. And so thank you to everybody involved. It wouldn't be what it is without you, and looking forward to seeing you all again next year.